When you look up at the night sky, you probably don't overthink the darkness. The sun went down, so the sky is black. It feels like the most obvious fact in the world. But for centuries, early astronomers like Isaac Newton held a specific model of the cosmos. They assumed the universe was infinite, eternal, and static, meaning it stretched out forever in all directions, had always existed, and wasn't changing shape. This creates a bizarre mathematical problem. Think of it like standing in a forest that goes on forever. No matter which direction you look, your line of sight will eventually hit a tree trunk. If the universe is filled with an infinite number of stars, then every time you draw a straight line outward from Earth, it should eventually hit the surface of a star. There shouldn't be any empty, dark patches. The logical conclusion of that idea is terrifying. If every line of sight ends on a star, the entire night sky should be a solid, blinding wall of light. Earth would be continuously bombarded by radiation from every direction, roasting the planet at 6,000 degrees. Because you can step outside tonight and not immediately vaporize, that simple observation of darkness proves that early cosmological model was flawed. The universe cannot be infinite, eternal, and static all at once. In 1823, a German astronomer named Heinrich Olbers tried to solve this paradox. He suggested that vast clouds of interstellar dust were blocking the light from distant stars, acting like a cosmic shield that kept the night sky dark. But the laws of thermodynamics ruin that theory. If an infinite universe had existed forever, that dust would absorb starlight, heat up, and eventually glow with the exact same intensity as the stars themselves. The dust would just become a glowing fog, and the sky would still be blinding. The actual answer requires throwing out the assumption that the universe has existed forever. According to the Big Bang model, our cosmos has a finite age of approximately 13.8 billion years. This diagram shows the present cosmic light horizon. Because light has a strict speed limit, it takes time to travel through space. We can only see objects if their light has had enough time to reach us since the universe began. We are effectively trapped inside a spherical bubble of observable space. The primary reason the sky is dark is simply that the light from stars beyond this horizon is still making its way toward us. Even within our observable bubble, there is a second physical limitation at play. Stars do not burn forever. They form, exhaust their nuclear fuel, and eventually die out. Physicist Edward Harrison pointed out that the cosmos is actually energetically poor. If you gathered all the existing matter and converted it into energy, there still wouldn't be enough nuclear fuel to keep stars shining long enough to fill the void of space with light. Then, in the 1920s, Edwin Hubble made a discovery that dismantled the last pillar of the old model. The universe isn't static, it is actively expanding. This illustration shows how an original wavelength of light travels. As space physically expands, the light waves traveling through it are actively stretched out. This process is called cosmological redshift. As the wave stretches, its frequency drops. By the time starlight from highly distant galaxies reaches Earth, it has been stretched into the longer infrared spectrum, rendering it completely invisible to the naked human eye. The expansion of space itself dilutes the radiation traveling through it, physically hiding the light that manages to reach our planet. Here is the strange reality. Olbers' premise was partially correct. If humans had the ability to see in microwave frequencies, the night sky wouldn't be dark at all. It would be blindingly bright in every single direction. This heat map shows the cosmic microwave background. This is the cooled, stretched relic radiation left over from the Big Bang itself, blanketing the entire sky. The fact that this intense heat has cooled down into invisible microwaves is a strict requirement for biology. To function, living organisms require cold sinks, places where waste heat can be dumped. If the sky were radiating at thousands of degrees, water would boil away, and complex chemistry would be impossible. We exist exactly because the universe is sparse, relatively young, and contains enough dark, cold space to allow life to survive. This timeline maps the universe's expansion. The flared shape on the far right represents dark energy, a mysterious force causing expansion to accelerate. Billions of years from now, this will stretch space so rapidly that visible galaxies will be pushed beyond our cosmic horizon. The light from those distant galaxies will be redshifted into nothingness. Eventually, the Milky Way and its immediate neighbors will be left completely isolated in an otherwise empty black void. The darkness of the night sky is the signature of a temporary universe. It had a definitive beginning, and it is heading toward an increasingly dark future. The starry expanse we see today is a fleeting privilege.